Hey guys, I'm continuing my investigation of this Admiral 30B1 chassis. If you recall from part 1, I found one badly charred resistor, one damaged power resistor that also measured bad, and a big old power resistor inside the high voltage cage that was open. So I replaced all three of those and tried doing a controlled power up on my Variac. But by the time I got to around 70 or 80 volts AC into the set, the one replacement resistor was getting really hot, so I shut the set down, and that's as far as I got. Well, one thing I should have tried, it just didn't occur to me at the time, was to pop the rectifier tubes out, power the setup with full power, and check the voltages, because without these being in the set, there'll be no rectified DC power going to the tubes or to the set. I will just have filament supply. So all the tubes should light up nice, should have 6.3 volts AC on all the tubes, and then I can put some probes down into the tube sockets and check the secondary AC voltages in these power transformers and make sure they're all right. Now, because this resistor was getting toasty and it's on the main B plus supply, I'm fairly confident that at least one of these transformers has a decent secondary. But the tubes were kind of dim because I couldn't get this thing up to full power, so let's check that right now. Alright, so let's give this a try. Power on. I'm just going to go right up to the full 117. And alright, let's see, this tube is lighting up. Can't see inside the metal tube, of course, and tubes I can see seem to be lighting up. I don't see that octal tube there glowing, but it might just be obscured by the getter or something. Alright, I can kind of peer down there and see the tubes on the other side of the chassis are glowing, and I can peer down through here into the high voltage cage and things are glowing. And on the big transformer we've got about 800 volts on the secondary. Now it's no load, so doesn't necessarily mean it's okay, but it's a pretty good sign. And the rectifier tubes are glowing before, so I think it's a pretty safe bet that the 5 volt supply is okay. That's odd. On this schematic they show two 5U4s, but I got a 5U4 and a 5Y3. And this is a 30B1, which is what I've got. So, although this is with the push-pull 6K6 audio output tubes, and this is single-ended, so this must be for the combo version where it's got a phonograph and a radio. Where's the one I've got? It's just... There we go. This is the version I've got, which is the 6Y6 for the output. Alright, so pins 4 and 6. Okay, same as the other guy. So 1, 2, 3, 4, 6. Alright. So, in spite of these transformers losing their waxy insides, I think there's a pretty good chance they're okay. They're ice cold right now. Let's check the current draw. Drawing about an amp, which seems reasonable for just the for all the tube filaments. There's quite a few tubes in this set. Alright, so that's good, although I do have a spare power supply or a chassis or two if I needed one. Alright, so why is that resistor frying? Well, this is the resistor in question that's frying. So this is the main supply coming out of here. Off the 5U4, capacitors, choke, dink, and that's roasting, which means something downstream has got to be drawing too much current. So I already checked that capacitor and I was able to form it up. I don't think that's a problem. Well, let's see. One part of this Goes directly to pin 10 on the CRT. I suppose it could be a short in the CRT, although, no, I tested it and there were no shorts, so. If there's a problem in the brightness control, like this is all shorted out the ground, well, that would be an obvious problem. What else have we got? Could be a problem with these resistors in here, so I think this 15K and this 3K, those are these two big guys. So I gotta check those too, if one of them shorted, or that could be a problem. Or if this capacitor was shorted out, well, there's a 6.8K resistor in there, so if that was shorted out, that resistor would probably be getting pretty toasty too. Let me check on that. Otherwise, 5K, 33K going to a tube, I doubt those would be a problem. 33K, it's a pretty sizable resistor, I don't think that would be a problem. 3.3K, and 4.7K, and that is it, as near as I can tell. So my best guess right now is something to do with these two resistors. Although more typically these go open, they don't short out. But, let's see. I checked these two power resistors and they were actually okay. It drifted off value a little bit, but not too bad. But I went ahead and replaced them anyways because I just don't like those cruddy old power resistors. So my investigation has continued on, and I'm doing, well, something that was fairly obvious I should have tried. Is I simply have my ohm meter going to ground, and then I checked either side of this resistor that was getting toasty, and on one side of it I've only got 38 ohms resistance to ground. That sure doesn't seem right. And on the other side, about 840 ohms, which also seems a bit low. But for sure, this doesn't seem right. So I'm going to trace out what connects to that point. There are numerous wires and components going there, so and maybe it's as simple as one of these wires has chafed and created a partial short to a chassis, or maybe one of these old paper caps is shorted out. Well, I started tracing out from this circuit point, 33K resistor, that measured fine, 33K resistor, that measured fine. And this is a jumper wire running from this point over to this point, and we got more components here. And I moved this capacitor out of the way, and looky what I found. A charred resistor. Now that I don't think goes right to ground, it goes to some other parts. As memory serves, it's a 4.7K, it should be identical to the one right next to it. Well, it's also going to one of these bumblebee caps that looks pretty horrible. So I'm thinking is this cap may have shorted out, which took out this resistor, which took out this resistor. So replace that, brown, black, yellow. That would be a 0.1 microfarad cap, 400 volts. That's how you read these guys, similar to the resistor color code. So brown is 1, black is 0, and then yellow is 4. You add on 4 zeros, or in other words, 100,000 picofarads, or 0.1 microfarads, and then the yellow stripe 4 means it's 400 volts. But now this isn't going right to, it is going right to ground, I think. Yeah, okay. Yeah, so this cap shorts out, that goes right to ground, this is dead short. Fries that. So, heck of it, let's check the resistance across that capacitor. I don't think I've ever found a capacitor that was dead short before like this. There's a first for everything. I've always heard that these, oh yeah, 0.3 ohms. I've always heard that these plastic tube encapsulated caps are really horrible. Really, they're just wax and paper caps inside of a plastic tube. Alright, so get that guy out of there. This is promising. That's one of the reasons I wanted to work on this set, was that just to practice my troubleshooting skills more than really getting this working. Because if you recall, I do not have a cabinet for it. Although, sure, I've got some Admiral sets that are unrestored that I could put this into if I get it running. But anyways, let's get those parts out of there and try firing this set up again. Alright, new 4.7K resistor, new 0.1 microfarad cap. When I took the old cap out, I saw that in addition to having some goo on this side, the whole thing is cracked. So, good riddance. Alright, so that was about another power-up test. Let's see, what have I got? About 80 volts. Looking at less than an amp of current. Increase the voltage a bit more. Nothing out of the speaker. Oh, and the raster. Oh, wait. I hear a high-pitched sound. No, the ion trap may have gotten a bit dislodged, so... Alright. Turn this set off and make sure that... barely warm. Much better. Huh, that one's almost cold, which seems a little... Ooh, that's hot. It's supposed to be a 15 watt. I put a 20 in there. I thought it'd be at least a little warm, but that's barely warm at all. Alright, I think I'm going to flip this chassis down so I can get the stuff on top. I want to check the ion trap, and I can check the high voltage at the anode and see if we got anything going on there. Okay, power up again. I'm go a bit higher with the voltage this time, so I'm feeling lucky now. Well, I don't know about feeling lucky, but at least I think I solved one major problem. Oh, nothing out of the speaker. Ooh. Alright, so let's see about high voltage. Nothing. Oh, wait, huh? Yeah, we got about 9,000 volts. Alright. So, this is brightness. Contrast. Alright, let's see what the ion trap. Magnets. What's this thing back here? Oh, yeah. Alright. Had become dislodged. That'll do for now. Alright, so having the vertical collapse is a pretty common problem. Alright. Clip on a wire here. Alright. How about that? That's the best height I'm going to get out of this. That's a pretty common problem. It's probably a leaky electrolytic on the vertical output tube, or some leaky caps, paper caps as well. Oh, and something else I want to do is replace that power switch. If you recall, it's fried and I just have it jumpered right now, so you can't turn the set off. I hooked up a better signal source, and set's not bad, except that the channel clunker is very dirty, so I need to clean that tuner out. Sounds not great. I've seen that often enough with these Admiral sets. The picture's not bad. Not bad. Might even be better. Channel 3. Vertical linearity's terrible, but it's a pretty good picture. Not bad at all. I just replaced the 50 microfarad cathode bypass cap on the vertical output tube, and that took care of my vertical height and linearity problems. So really the only significant issue left with this set is the sound. Now, if this is anything like the Admiral 30A1 chassis I restored not too long ago, there are some exposed mica caps inside the IF cans, so I think that is what I will take a look at next. But it's getting late, so I will save that for tomorrow.